Hello, this is Mr. Stansbury. I'm going to take you through the notes on experimental probability. At the end of this, you should be able to say, I can estimate the probability of events in an experiment. Okay, so first thing, the chance of an event happening is a number between 0 and 1 inclusive, which means it can include 0 or 1. Okay, this number is called the probability. An impossible event has 0% chance of happening. That would be probability equals 0. Okay, and then a certain event has a 100% chance of happening. That probability would equal 1. Okay, and then all the other different percentages would be somewhere in between that. So if it had 50% chance, it'd be 0.5. Okay, so there's some important information to know about terminology in probability. One of those things is the number of trials is the total number of times the experiment is repeated or performed. The outcomes are the different results possible for one trial of the experiment. So all the different possible things that could happen. The frequency of a particular outcome is the number of times that this outcome occurs. So like if we were going to flip a coin 10 times and 6 times we got heads, the frequency of heads would have been 6. Okay, and then the relative frequency of an outcome is the frequency of that outcome expressed as a fraction or percent of the total number of trials. So again, if we flipped a coin 10 times, 6 times it came out heads, the relative frequency of heads would be 6 out of 10 or 60%. Okay? Now, let's take a look at some of this info here with an example. A fluffy unicorn is tossed 130 times. 88 times it falls on its side. 31 times it falls on its feet. And 11 times it falls on its back. The number of trials is 130. Okay. The outcomes are falls on side, falls on feet, and falls on back. Okay. The frequencies are side is 88 right here. Feet, landing on feet is 31, and landing on back is 11. Okay. So the relative frequencies are side, which is 88 out of the total trials, 130, which is 0.677 or 67.7%. Feet is 31 out of 130, which is 0.238 or 23.8%. And then back is 11 out of 130, which is 0.085 or 8.5%. Okay? So that's this stuff here put into an example to try to help you understand. Okay, something else important to note. If no other trials are performed, the relative frequency of each event is our best estimate of the probability of that event occurring. So basically what we're getting at is the experimental probability is the same thing as the relative frequency. And remember, relative frequency is the frequency that an outcome is the frequency of that outcome expressed as a fraction or a percent. Okay, so the relative frequency is basically the same thing as the experimental probability. Okay, so like if we flipped a coin 1,000,000 times, we would expect that to eventually get really close to 50%. So we would expect that our relative frequency should get pretty close to 50%, and that would be our experimental probability. Okay. All right, let's take a look at an example here. So we've got example 1. This table shows people's treat preference from 3 different cities. Okay, so we've got Screamer, Alabama, Two Egg, Florida, Bug Tussle, Kentucky, and then we've got Top Ramen flavored Pringles, fried chicken flavored Oreos, and pineapple flavored Kit Kats. All right, so they're asking us to do 3 different things. Estimate the probability that someone whose favorite treat is fried chicken Oreos is from Two Egg, Florida. Okay, so what we're doing is, let's see, there's 526 total people that participated in all of this. Okay, but what we're trying to figure out is the probability that someone whose favorite treat is fried chicken Oreos is from Two Egg, Florida. So we're only going to look at the people whose favorite treat was fried chicken Oreos. So that is our 178. So we're only looking at the 178 people whose favorite treat was fried chicken Oreos. And then what's the probability that those people are from Two Egg, Florida? So then here's Two Egg, Florida. 84 of the 178, 84 of the 178 people whose favorite flavor was fried chicken flavored Oreos. 84 of those are from Two Egg, Florida. Okay, so if we get our calculator out, we do 84 divided by 178, and we can write that as 0.472. Okay, or 47.2%. Okay, so you can write it really any one of these three ways. I kind of like the percent the best. It kind of gives me the best idea, but any one of these three would work out just fine. Okay, just as a side note to try to, if that was a little confusing for you, let's do this. Let's say if you pick any person at random, what's the probability that their favorite treat is Top Ramen flavored Oreos? We have a total of 526 people that were surveyed, and all the people whose favorite were Top Ramen Oreos would be 158 of those people. Their favorite was Top Ramen Oreos, 158 out of 526, whatever that would give us. Okay, just that's like a little bit more simple example than this. Kind of went straight into a little bit more challenging one, but I think you're up to it. Anyway, B, estimate the probability that someone's favorite treat is Top Ramen flavored Pringles. Apparently I got ahead of myself because that's exactly what we just did there. Sorry. That is going to be 158 people. Their favorite treat is Top Ramen flavored Pringles, and then the probability that someone's favorite treat, yeah, so that's just out of 526. So it's just interesting that they asked us a little bit more challenging question first, and then a little bit more difficult one. Okay, so we take 158 divided by 526, and we get 0.300, or 30%. 30% chance. Okay, and then last one here, estimate the probability that someone's favorite treat is not pineapple flavored Kit Kats. Okay, so total number of people then, because this is from everybody, is the 526. And then the people only 190 people, their favorite treat was pineapple flavored Kit Kat. So this top number really is going to be the 526 people minus the 190 people whose favorite treat was pineapple flavored Kit Kats. So this is going to give us the total number of people whose favorite treat was not pineapple flavored Kit Kats, right? So let's do 526 minus 190, and that tells us that 336 of the 526 people, that was not their favorite treat. So take that number divided by 526, and we get 0.639, or 63.9%. Okay, whichever one floats your boat. Okay, that is all there is for the notes on experimental probability. If you have any further questions, please feel free to ask in class. Thanks.